Okay, here are the solutions to the activity for section 1.6 on limit laws. The first example here, the limit of that third degree polynomial, is an example where we can do direct substitution. So we evaluate that polynomial at 2, and we should get a limit value of 43. Similar to the second example, we check to see if that 2 causes a 0 in the denominator. It does not. It causes 9 in the denominator, so we can evaluate directly again, and we get 14/9. The third example looks very much like the final example I did in the introduction. We multiply that thing out, combine some like terms, and we're able to factor out an h from numerator and denominator, and we see that that limit is 10. Okay, the fourth example, again, here we check and see that the 1 does cause a problem in the denominator. So as I'm thinking about factoring this then, I'm hoping that I can factor this term out of the numerator so that they will cancel. So when I went to factor the numerator, the first thing I wrote down was h minus 1. And I asked myself, can I multiply that by something to get 3h squared minus h minus 2? And the answer is yes, 3h plus 2. So we're able to factor out those h minus 1s. I want to point out again here, it's really important to bring the limit notation along until you've evaluated. Sorry about that. So right here, I'm evaluating this directly at 1, so that's why I lose the limit notation. I'm now taking the limit. Up to that point, I'm doing algebra to get to a point where I can take the limit, and so the limit notation comes along. If you prefer to do the algebra on the side and then bring that back over with the limit notation, that would be acceptable as well. Okay, one more example here, and here's the example where we need to multiply by 1. And we're going to multiply by 1 in a nifty fashion. It's going to look something like this. We're going to multiply by the square root of x squared plus 25 plus 5 divided by the square root of x squared plus 25 plus 5. Okay, we have to, if we're going to multiply by anything in this situation, it has to be 1, first of all, because we won't be changing the value of the limit. And let's see why this works out so nicely. So what happens? We get the limit as x approaches 0 when, let's do some color coding here. When I multiply these two terms, the square root goes away, and I get an x squared plus 25. Okay, the next set of products would be this times this, which gives me 5 times the square root of x squared plus 25, and then this times this. So I'll put those in the same color, because that gets me minus 5 copies of the square root of x squared plus 25. And finally, the last product to handle is this times this, which gives me a negative 25. Okay, and we still have in the denominator x squared times the square root of x squared plus 25 plus 5. Okay, so what happens then? We do some simplification in the numerator. We get the limit as x approaches 0. We have the two red terms are a positive of the same term and a negative of the same term, so those go away. We have a positive 25 and a negative 25, so those go away. Let's see, this term cancels with this term cancels with this term, and the only term that's left then in the numerator is x squared. And the denominator comes along as x squared times the square root of x squared plus 25 plus 5. Now we see that we can, because only multiplication is happening, or because multiplication is happening there in the denominator, we can simplify one step further. We get the limit as x goes to 0 of 1 divided by the square root of x squared plus 25 plus 5. And let's see, as x goes to 0, I guess nothing's changing in the numerator. I'm taking the limit now. I'm evaluating at 0 because I can directly substitute. That's why the limit notation is going away. When I do that, x 0 squared is 0, so I get the square root of 25 plus 5, which is 1/10. So we showed that original limit, the limit as x approaches 0, the square root of x squared plus 25 minus 5 divided by x squared, this limit is equal to 1/10. Okay, should see some more examples like this in the 1.6 homework, so head in to the textbook and give that a shot.